let's go through this. All right. We're going to go over relations and functions. Okay, and this is going to be some words we're going to talk about today. Relations, domain, range, and function. Okay. Now, at some point, we think about a function as kind of like a function box. Okay? You're putting in some value, all right? And that value is going to be an x. And just like when we had this function during the warm-up, y equals x plus 3, we put in some number for x, and we got back whatever y was. Okay? So x could be anything you wanted it to be. So that made it independent. Okay? Whatever you wanted this x value to be, you could put it in there. And once you plugged it into the function itself, then you would get back some number for y. Well, that became dependent. Okay? This y value was dependent on what you plugged in for the x. Okay? So we also are going to talk about x being the domain and the y value being the range. Okay? By the way, this gives you your ordered pairs that you're going to have to do to graph these functions. So you're putting in an x and you're getting back a y. And you put them into an ordered pair. All right, so as we do this, okay, we're just showing all this function is shows the relationship between the x and the y values. Whatever you're putting in and whatever you're getting out. You're going to show that one of three different ways. A table, a mapping diagram, and then a graph. All right, so let's look at this. So we have three ordered pairs or three relationships. This y depends on this x. This y depends on this x. This y depends on this x. So as a table, we're going to set this up as our x values and our y values. Okay? And so when I plugged in this x value, I got this y value back. When I plugged in this x value, I got this y value back. And when I plugged in this x value, I got this y value back. So that's the table. All right? As a graph, clearly we can see here that this is just a matter of us being able to plot points. All right? So 2, 3, 4, 7, and then 6, 8. All right, that's the second way. That's the graph. And the third way, and this is kind of one of the more important ones. We don't think about it as important, but it's going to be important when we decide whether or not this is a function or not. Okay? You can use circles. You don't have to use circles if you don't want to. But I'm saying, okay, my domain is 2, 4, and 6. My range is 3, 7, and 8. Okay? So this 2 maps to that 3. This 4 maps to that 7. This 6 maps to that 8. And that's a pretty easy way of being able to look at this in a pretty easy situation. So what I want you to do is I want you to do this one right here. Express the relationship, these points, as a table, mapping diagram, and a graph. All right. So in this case, my x values 1, 2, 3. Here we have 3, 4, 5 for my y value. The mapping diagram. So we have 1 is mapped to a 3. 2 is mapped to a 4, and 3 is mapped to a 5. When we plot the points, 1, 3, 2, 4, 3, 5. We're not connecting them. Now, we've touched on this a second ago, but the domain, the first set of the ordered pairs are the x values, the range, the second set of the ordered pair are the y values. Now, what's the domain of this mapping diagram right here? Marissa? Okay. Well, think about it. Time out. Time out. All right. From a table, what's my domain? 1, 4, and 8. What's my range? 1 and 4. Okay? You don't have to repeat the number, although you can, it's fine. But again, we're just using two different numbers, 1 and a 4. Okay? Now, this is where I need everybody to pay attention. Okay? Because this is where we're going to get in trouble. You see, this is a continuous function. It continues from this point to this point right here. Okay? So do you agree with me that on this function right here, we're using all of the x values from here to there? And we're using all of the y values from here to here. Do you guys see that? Everybody? Okay. So then when we're writing the domain for this, we're talking about all of the values of x between 1 and 4. The range, we're talking about all of the y values between 3 and 4. Do you understand that? Yes. 1 and 4 is 5. I'm sorry, you're right. 1 and 5. Thank you. Okay? Oh. All right, so remember, for the domain here, we're talking about all of the values of x between what two numbers? -4 and 6. Very good. Okay? We're using all of these x values. Everything in between. Okay? All right, I want you to find the range for this function. When we're talking about the range, we're just talking about the y values. Okay? And when we do this, I'm only using the y values on this graph from here to there. Okay? I'm not using any y values up here, and I'm not using any y values down there. So we're using all the y values between -2 and +2. Okay? Perfect. You guys tell me the domain and the range of this function. For the domain, we're using all the x values between what two numbers? 2 and 6. And the range, the y values, we're using all the y values from what two numbers? 0, -4. But which one goes?
-4 to 0.
-4 to 0. Very good. So remember, the smallest number goes on the left. We said it a bunch of times during compound inequality. Thank you for football. All right, so for this next set, I want you to draw a mapping diagram, and I want you to tell me whether or not it's a function or not. So for my domain, I have a 3, I have a 5, and I have a 4. My range, I have a -2, a -1, 0, and a 1. So we have a 3 that's mapped to a -2. We have a 5 that is mapped to a -1. We have a 4 that is mapped to a 0. And we have a 3 that is mapped to a 1. Is this a function or not? Not a function. Good job. All right. Give me the domain and range. All right, this is a continuous function. So my domain is all the values of x between what two numbers? -5 and 3. My range is all the values of y from what two numbers? Somebody else. Anybody. Close. -2 to +1. Okay? All right. And so that just kind of gives you more of an example of it right here. Easy. All right. We're going to stop it there.